Yes. Good evening, all of you. Good evening, Dr. Thakkar. Good evening, Mr. Manish. So, I request Dr. Thakkar to please start the presentation.
Okay. Thank you, Mr. Manish. On behalf of the Textile Association Ahmedabad unit, I welcome everyone who are joining this particular program, which is thoda hatke, because normally we carry out programs for the core technologies of textile like spinning, weaving, processing, designing, garmenting, etc. This is probably the first time we have planned to have an event for energy, and that to energy management. So definitely, Mr. Jain, I thank Mr. Jain, Felidae system, who in fact inspired all of us to have this kind of program, which is I'm sure will be highly beneficial to all our members who are running any kind of manufacturing unit, whether it is spinning, weaving, centralized, decentralized, organized, unorganized, whatever is the mode of organization. For all of them, this is going to be very, very important. So I also thank the president of the Textile Association Ahmedabad unit, Shri Hasmukh Bhai, who is also member of parliament from Ahmedabad constituency, Mr. T.L. Patel, Mr. A.D. Patel, Shri Harish Bhai, and the whole team of Ahmedabad unit, our office secretary Maiti, and everyone who have supported for the successful conduct of these particular program. So with these few words, let us start with the brief presentation which I have, and then I'll let Mr. Jain to take it over. So whenever we start talking about the energy, we always have in mind the conservation, because today we are living in a world where reducing energy, conserving energy, using renewable sources, all these words always we keep on hearing, and we try to make sure that the energy consumption gets reduced. Okay, so need of energy conservation has assumed paramount importance due to the rapid growth of process industries causing substantial energy consumption in textile operations. This has made pathways to conservation of energy, which can be affected through process and machinery modifications and implementation of technological advancements relating to process optimization, as well as development of newer methods to meet the challenge of substantial energy saving in textile processes. So this particularly whole process involves replacing the methods from conventional to the modern methods. Fine. Global energy crisis as well as high cost of fuels resulted in more activities to conserve energy to maximum extent. The textile industry retains a record of the lowest efficiency. Remember, we are using the word lowest efficiency in energy utilization, and is one of the major energy consuming industry in the manufacturing sector. So we need to take this particular fact in mind, that we are the lowest efficiency in energy utilization, and we again are highly the great consumers of energy as well. When we look at the entire process chain, the production chain of the textile, we can see that about 34% of energy is consumed in spinning, 23% in weaving, 38% in chemical processing, and another 5% for miscellaneous purposes. Power electrical. When I say power, I definitely mean the electrical power dominates consumption pattern in spinning and weaving, while thermal energy is major for chemical processing. And it is also known that the thermal energy in textile is largely consumed in heating and drying and etc. Whereas fuel consumption in textile is almost directly proportional to the amount of water consumed. Okay, so this particular fact is highly eye-opener for all of us, that spinning and chemical processing need more attention because they consume large amounts of energy compared to weaving, of course. Garmenting, of course, is the branch which consumes least amount of energy. So obviously we need to focus more on these areas to find out how to optimize the energy consumption pattern, which will also lead to energy management system. Okay. So when we say a share of manufacturing cost factors, suppose if you are making 20 tex combed cotton yarn, and if it is manufactured in several countries, then how the cost of manufacturing is distributed amongst various parameters. Like raw material, of course, will be number one, because most of the contribution will be of the raw material. This is true for any manufacturing system. But you can see the variation. uh, it is ranging from as low as 40% to as high as 61%. Like 40% is the component for Italy and 61% is the component for China, whereas India stands at 51%. So out of the total manufacturing cost, 51% goes to raw material. Wastage 7%. We have large amount of wastage, which is more or less common to all the countries. Labor, again, it will be of course higher for Western countries. Like Italy will have a very higher share. US again will have a very higher share. Rest of the countries are more or less into the same group. Next item, what we are discussing right now is the energy. You can see a lot of variation as far as the energy percentage into the entire manufacturing cost is concerned. You can see it ranges from as low as 5% for Brazil to as high as 12% for country like ours, India. So this particular figure itself speaks a lot about thinking about how we are consuming or rather wasting energy produced so expansively by the country. And a lot of sectors are striving for the energy. Auxiliary materials and capital cost. We will not talk much about it because you already know about what is the capital cost involved into the textile manufacturing chain. So right now, let us focus on how can we reduce this 12% to not 5%, but maybe 10% or 9% or even 8%. That will be excellent. And that is going to be the topic of today. Of course, Mr. Jain, Mr. Manish will talk more about how effectively you can carry out several operations right from first to last manufacturing sequence. When we look at the breakdown of typical electrical energy used in a composite textile mill, as we know, right now we will not focus on the unorganized or decentralized units. But when we talk about the composite textile mill, then the breakdown of the typical electricity used in a textile mill is as is seen in front of your screen. The maximum part is, of course, again of the spinning. Right now, we have taken the example of the ring spinning system, but the figures for rotor spinning will be more or less same, because the main power consuming sector, of course, is carding and the ring spinning. But overall, if you look at ring spinning is again a major spinning system. Then humidification comes next. We need humidification in the entire plant. Then, as you can see, weaving preparation, wet processing, and lighting and others. This is how the entire electrical energy which we use in a textile mill is divided. Okay. Uh, when we look at, again, fine tuning the previous slide, when we look at whatever energy we are using in our textile units, out of that, uh, which are the processes from mechanical point of view or electrical point of view, how this particular energy is distributed. So as can be seen, motor driven systems, because we have most of the operations are motor driven operations, so that consume and also the steam is of course part of the thermal energy, so we may not focus much on that. But the item which we may focus is motor driven system. So all the machines are driven through motor. So that consumes 28% of the energy supplied to the textile mill. Then fired heater, again, it may be fuel based, facilities, cooling, etc., and other. So our focus should be made on when Mr. Jain talks about how efficiently you can carry out the operations, even if it is a fully motor-driven system. Of course, any manufacturing system will be a motor-driven system. Now, when we look at where are we losing onto the energy, whatever energy we supply, there are a lot of losses into the total energy supplied. So, out of the total energy provided to the manufacturing scheme, uh, roughly 64% of the energy is utilized to carry out a particular process. Remaining 36% is some kind of a loss which company has to bear. Out of these, as you can see, the major loss is coming out of motor system. So motor system account for the maximum loss into the energy, about 13%. Boiler losses again are 7%, but these are mainly thermally operated or fuel operated. Then the equipment losses and distribution losses. So our focus will be mainly on how efficiently we can improvise onto our entire drive system, entire consumption pattern, about the distribution losses, etc. So what can we? This is of course a slide from a person who is basically a textile engineer. Of course, I'm not an electrical engineer, but putting some facts from textile point of view. What could be the scope for an increased output per unit duration of various electrical driven machines? Use of high efficiency motors in place of standard motors with proper application will save 2 to 4%. Mr. Jain can throw more light onto this. Even more saving can also happen. Replacement of undersized and oversized motors. Yes, this can be true in many cases because we might be running machines which are quite old and may require a different type of motor or different size of the motor. So definitely understanding this particular fact will be quite interesting. Use of high temperature grease according to insulation class of the motor. This is more technical point. Probably we'll understand more from Mr. Jain. No load power study of motor. Replacement of motors consuming high or no load power. This again is a technical point. Mr. Jain will throw more light on it. Investigation of exact burning reason, rewinding as per original technical data. These are again, as I'll repeat, these are the points from the textile engineer. So more definitely we'll be able to hear from Mr. Jain. Uh, when we talk about a strategic energy management program, of course, later on part we'll have a detailed program of how strategically you can design an energy management system and how and what kind of beings are connected with this. So make commitment. Of course, you have to decide that I want to have a system or a management program in place, assess performance and set goals, reassess if required, and under that, create action plan, implement action plan, evaluate progress, recognize achievements, and if required, go through the closed loop of reassessment. Fine. So this is what I wanted to convey from my side. So it is over to Mr. Manish Jain, who will definitely talk in detail about how this particular system can be implemented in a textile unit. We'll take all the questions at the end of the program. So over to Mr. Manish.
Thanks, Dr. Thakkar. I would like to thank Mr. Patel to spare some time for this webinar and gracing the occasion. Good evening, everyone. My name is Manish Jain from Felidae Systems. So today we are going to talk about how do we manage the energy in textile plant. So brief introduction about ourselves. Like we are based in Noida. We have been working in energy sector in the energy audit, energy management, energy monitoring. We have been doing the quality control automation, multiple type of automations we have been doing, and this organization was established in 2012. So the kind of industries we have been working with is FMCG, rubber and plastic, textile, of course, automotive, and uh, consumer appliances. That's right. So the idea of our organization is to go digital. Now, I mean, today we are going to talk about energy management, but digitalization is a core technology which is paramount of today's time. So now it's not a fancy word. I mean, go digital is not just a fancy word. We have to embrace this technology, the advanced technology of the digitalization, so that we can monitor our processes very closely. We can find out there are so many data techniques are there, data analysis are there, so that we can find out where the losses are, where we can improve the efficiency, where we can improve the quality. And by just increasing the quality, that means we are reducing the wastage, and by reducing wastage means we are increasing our baseline. So it's all together, right? I mean, we should be able to start monitoring first, and then we can control using the cutting edge technology. And in this go digital concept, we are providing information about energy, productivity, uh, some kind of some operations, centralized operations, which will reduce human error, and which will reduce the downtime. I mean, every little inefficiency cost of money, and by reducing any of such of inefficiency, we can increase our profitability. And apart from that, we have been working in safety and energy audit and infrared thermography as well. These are just to keep your utility safer, right? So, a quick poll here. Uh, just want to know, like today we are going to talk about energy management. So how many of you feel why the energy management is required? Is it just to reduce the running cost, to reduce the impact on the environment, to make facilities safer, increase the confidence of the customer and the shareholder? Now, all the bankers, all the investors, they are looking for how sustainable your operations are. Sustainability is the key thing of the time going future, and this, for sustainability, the energy is the paramount factor. So okay, so I can see there are results. So result shows that 11% think that it's just for reducing the cost. Nobody thinks that it is just to have the reduction in impact on the environment. Yeah, I mean, 66% think that all of above. Yes, that's right. Uh, Energy management is just not for saving the cost of the production. It's not just to make your facility safer. Is about many things. So when we are thinking about energy management, we don't have to think about like immediately how much energy we'll be able to save. Think about the concept. I mean, going to the shareholders, going to your marketing team, going to your customers. I mean, some of your customers may be from overseas. When they see that your facilities, I mean, you are socially responsible and responsible for the sustainability of the plant and the environment. So it will have a good impact on that, right? So, so basically, when we are talking about energy management, in case of power or energy management in any plant, I would like to say that there are two ways of how the energy is being consumed. One is the utility, and is the production. So these are the major, consumers. I mean, how we can distribute. I mean, utility is something which is handled by utility or the maintenance. I mean, whatever is called in. It all depends upon the industry to industry. So in case of utility, the utility is responsible for providing energy to the production unit. So basically production unit is the consumer or the customer of utility section. And the production is like where the energy is being used, right, in general operation, as Dr. Tucker detailed described, like what all different functionalities are there in textile and how the energy is being used from from production point of view. So in case of utility, in any plant, in any plant, like we have electrical energy, compressed air, steam, and now solar generators, and so many things, right? I mean, further, if we divide these utility energy section, there are two type of energy monitoring or energy management. One is like energy generators or energy suppliers. The second is energy consumers. So, for example, compressed air is an intermediate device which provides energy to the production machines by providing the compressed air. At the same time, it's a consumer for the electrical energy. Same is the case with the steam boilers. I mean, if it is electrically fired, then I mean definitely the electrical energy is the energy, but it's mostly like thermal fuel based boilers, and they do provide energy to the production unit. And on the supply side, like I mean, we have auxiliary energy supply like DG, which is a standby energy generator, and the energy which we purchase from the discom. So these are the and of course, I mean, we get the energy at like say 33 kV or 11 kV, and then we have to reduce it to make it usable. So there we have transformers, a series of transformers, and so that we can step it down to the usable limit. And nowadays we have been using solar. So solar is a key component nowadays for energy management, because one way it becomes very cheap for generation of the energy. Second way, I mean, there are so many debates available. We have to see I mean, what are benefits are provided by the government. We have seen that many companies, they don't know what are the benefits there. So we don't go into solar, but that is another thing. But at the same time, we have to monitor what is the energy is being generated by solar. So we have to manage the supply and demand, both the things. And for the from the utility section point of view, the responsibility of the utility manager is very high, because he is the one who is interacting with discoms. He should know where my penalties are coming from, or if I have to change any, some kind of tweaking the production schedule, I can reduce my energy bills, right? Or if I have to purchase, for example, in many states we have uh, uh, exchanges through which we can purchase. I mean, if you have 1 MVA and above load, you can purchase power directly from the exchange. So you can go for bidding process, and you can reduce your energy cost by as much as 10 to 15%, which is huge. So 10-15% in energy savings is a big saving. So these are the points where the utility manager has to take a decision, and he has to know what my energy consumption patterns are, and how my energy is supplied to the production unit. So this is the basic idea for energy management from utility point of view. The second is the production section. As Dr. Thakkar said, like I mean, in production we have very different type of areas where the energy is being consumed. Of course, the major is the motorized units, right? The spinning mills and some uh, pumps are there, and all the machines are mechanically driven, which is which is provided by the motorized system. Now, in this, the interesting point here is how we can reduce the energy consumption in production. One is like, I mean, if we conduct an energy audit, we see that there are so many leakages, and we reduce the leakage, and then we can reduce the energy consumption. I mean, we can reduce the leakage, but reduction in the leakage is still not, I mean, of course it's a saving based on what we have been consuming, but this is still not a real saving, because the leakages are just inefficient processes which we have stopped, right? But we have to make our utility of our production facility more smart. I mean, rather smarter, so that it starts saving further. And you know, I mean, for example, if you start going to gym, it's not just that you are reducing your weight, you are making yourself leaner, you are making yourself healthier and fitter. So the moment we start reducing or focusing on the energy consumption of the production unit, we become more efficient. When I'm saying this, it will like, I mean, what I mean is like, when we start monitoring the energy consumption of each and every manufacturing process, will have a knowledge about what my baseline should be, right? And my operations will be efficient, and any type of failure, it can if it is going to happen, it will be easily predictable. So in case of production, like what we do is, I mean, it's a common PDCA check. Like, we do plan, do, check, and act, right? So it's a continuous process. We need to do lot of planning, how we are going to monitor uh, the facility, uh, and then we have to take action. Then we have to check what has made a change in the like, I mean, how we have how we have to make a checkpoints, right? What is the thing, I mean, which we are going to monitor, and then we have to act on that. And then again we have to plan based on what is the outcome of the act. Now, coming to the specific to production unit, the parameters which are very, very important is that, I mean, you don't need to, I mean, right now you don't need to have any investment. I mean, you can start effectively by zero investment, by just started managing your facility. What you have to do is you have to start monitoring how much energy consumption are there for each and every process, and how much is the specific energy consumption. Now, specific energy consumption is very, very important, because assuming that we have, say, 10 similar type of machines, right? And one machine, let me just tell you the specific energy consumption. The specific energy consumption is the unit of energy consumed in producing one piece. So, for example, if it's a spinning mill, how much energy is being consumed in manufacturing, say, 1 meter of thread, right? So, or maybe the 1 meter of the cloth, or the processing of the cloth. So, I mean, per unit, per meter, or I mean, thickness of the cloth or the thread, I mean, that can also be taken into account. But what I'm saying is, I mean, it has to be based on what physically you are producing. We need to monitor how much energy is being consumed. Now, if suppose you have 10 units of the similar type of processing, what we have to do is we have to monitor the specific energy consumption of each unit. And then we can find out, I mean, once you start putting all the data in Excel sheet, just start putting that data in Excel sheet, and by the end of a week, you will have some kind of baseline. You will have figure in your mind that in producing 1 meter of thread, this should be the energy consumption. Now, this is a very, very important parameter, and this is highly important in the sense that this will tell you the behavior of your production. So, for example, coming back to like when I'm talking about the baselining, so one of the aspect is like baselining the specific energy consumption. The other is how much is your no load baselines. So if you start, so the idea here is like, I mean, if you let your machine run for say 15 minutes every fortnight, right? I mean, initially you should start doing it for every week. So every week, if you let your machine run for 15 minutes or 30 minutes with no load, and start monitoring the energy consumption within 30 minutes. Now, this is a baseline of your no load losses. So so I mean, if it is getting increased every week or every fortnight, so that means there's something wrong, right? So I mean, of course, we do greasing as Dr. Tucker suggested in his presentation, that using high temperature grease. I mean, of course, these are the technologies which are available to us. We should start using it. And if suppose we have say different type of motors, right? I mean, in industry, the common practice is rewind the motor. It's not suggested to rewind it for more than twice, but still we do. I mean, we think that, I mean, the capital cost is, I mean, we are saving the heavily on the capital cost, but it's not the fact. The moment we start monitoring these parameters, that what my losses are because of rewinding the machine, motor, so I'm losing more than the capital expense which I'll be doing. Now, this is very important. Once we have that data, it will be easier for us to, convince our management. And the moment we know what is the cost of, rewinding of machine, and you, nowadays the cost of motors are going down, cost of VFDs are going down, so there are so much of reduction in the cost. So there are very efficient technologies are there. There are IE5, IE4 type of motors are there. We should go for that. We should start implementing that. And one very important point which Mr. Thakkar has raised, that underutilizing or the overrating of the motor. This is very critical point and very important point, because when we purchase a machine designer, the machine manufacturer may have supplied based on some, you know uh, old technology, like the gearbox, or the type of lubrication was there, or he may have taken into account, say, 125% of the load. But in general, I mean, when we are seeing that, I mean, the load is not going more than 60%, why do we have to use high rated motor? So the moment we reduce the motor rating, we can start saving huge. And the best part is that these motors can be used somewhere else as well, right? So I mean, we are not going to, we don't need to go and throw it. Now, how will it be possible? It will be just possible once we start monitoring the energy consumption parameters, right? If there are any changes by because of change in the production situation, right? I mean, we should do that. So this is about the production, but the holistic view of energy management is that, first of all, we have to analyze how the energy bills are, designed. We know, in many industries, uh, we go to, like, they know that electricity bill is something like which we can't do anything. I mean, it has come and we have to make the payment. That's it. We don't know, like, there are so many hidden treasures within the electricity bill. By simple measurement and by simple monitoring these parameters, we can reduce 3 to 4% without doing any other thing. So there are many things. The contract demand may be more. The power factor may have been. I mean, of course, power factor is very much known, but still, I mean, if we are putting the power factor panel, still maybe because of harmonics, we are not able to control the power factor as much as it should have been. The voltage variation, of course, I mean, it does not come to the energy bill, but uh, I mean, you can go to your electricity distributor company. They can provide you the meter record. This is called MRIs. So in that, I mean, you will get the history of the voltage variations. So that these things are already there. I mean, they have to support you for this. And we have to find out what are the penalties are there, what are the rebates that we could have availed, and what are the, TOD billing. I mean, the TOD billing is like time of day of, because uh, in many distribution company, how do they charge is like they have a different tariff plan for morning to evening and evening to night and night to morning, and so on and so forth. So if we can tweak any of your production scheduling, right? I mean, we can have, the energy consumption as low as 30% or 40%. So I mean, in some utilities, the difference between the highest TOD and the lowest TOD is just half. So you can say 50%. But I mean, of course, it should support your production pattern. But having said that, there are so many other processes which we can just sit with the production unit and we can find it out. Okay, I mean, if these are the energy consumption processes, and if we can move it to the lower TOD billing, we can have a better energy management. And then again, I mean, in this production side, we have to know the trend of energy consumption patterns and establish the baseline for the consumption. And believe me, I mean, you can just take my word. The moment you start, what you have to do is you don't have to spend more than 15 minutes a day. Once you start baselining your energy consumption, you will have power to control your utilities very easily. You will be able to surprise. You will be surprised to see how much potential is there. So baselining, I may be emphasizing it more and more and more every time, because baselining is something like which will tell you like this is one parameter. If you can just start monitoring for each of your process, you will have huge information about your process. And trend is very important because in many process, like I mean, for example, right now this humidity is high, so some of the processes like humidification will cost less, but in case of dry environment, the humidification cost will be higher. So we need to know like how much impact of the environmental condition is making in our energy consumption pattern. So the ideally, like I mean, we need to have data of over the year. So the more the data, the better you can control your energy consumptions. And of course, I mean, once we do know like this is what is my baselining based on the environment and based on the external, and it will be based on my the product type. So all together we can find out where I'm where my baseline is. So the moment you have baseline, you can control all of your energy consumption. And these are the losses. Of course, I am pretty much sure that we all have seen these losses once or twice. But let me just brief you in a quick way. One is like low power factor, poor power factor. Power factor is a critical and very critical parameter. Not only just for billing purpose, you may have a better power factor at the end of uh, uh, billing station, right? I mean, near the transformer. But I would suggest if your facility is bigger, start putting the power factor correction panel at a distributed location, because that will reduce the losses of the cable also, and the load on the cable will go down. The I square R losses of the cable will go less, reduced, and at the same time you know your switch gear, the load on the switch gear will be reduced. The facility will be safer, and the correction of the power factor will be much better. Unbalanced load, which is not the case in many of the textile units, but in garment industry, yes, because there we have lots and lots of single phase loads. So that's a challenge in garment industries. We have seen that it's next to impossible to have highly balanced load in garment industry, because I mean, this sewing machines are such that, I mean, in one phase there are 100 machines, another phase maybe 80 machines, and so on and so forth. So, but the point here is we have to maintain within certain limit. It is a parameter which, especially where we have more and more of single phase load, we have to maintain as much as possible. I won't say that we will be able to maintain 100%, but to certain extent, because it has many repercussions. The first and foremost is it will have an impact on the power factor correction, and the neutral current will be increased, and the facility will be, you know, not safe. And overloading, underloading of the motor, of course, I mean, that we have already discussed. Higher harmonics. Harmonics is uh, more talked about factor now. Harmonics are like because all of our alternating current is sinusoidal, right? I mean, any injection of different other than 50 hertz frequency, that's called harmonics. And these harmonics are generated by switching loads. So switching loads are like the one we have in anything where we are converting AC into DC and then converting to AC back. So, I mean, nowadays, uh, it's very surprising that although we are using all AC, but most of our devices are going into the DC. For example, the laptops, the computers, or the LED lamps, or nowadays this BLDC motors. These are all DC devices now. But the problem is, I mean, we have to convert AC into DC and DC and then AC. So, I mean, all this conversion will induce harmonics, and these harmonics will have a lot of losses and unsafer your facility. Cable losses we have already discussed. The more the current on the cable losses will be more. So if we can reduce the current, something which, and of course, if we can reduce the current consumption on the load side, the current flowing in the cable will be reduced, and so will be the cable losses. Overloading your transformer, again, I mean, it completely depend on the current consumption. And in inadequate cleaning and maintenance, we have already discussed about I mean, if the greasing is not proper, if the lubrication is not proper, the losses on the mechanical losses will be increased. So, in case of lubrication, and so we should try. I mean, if we can have some kind of automated lubrication system, there are some systems available nowadays that your machines will be lubricated automatically. So you don't have to schedule. I mean, first of all, like, I mean, you don't have to plan. Uh, schedule a downtime, and we have to see, like, I mean, the lubrication is done or not, right? So it will be lubricated automatically. So again, so now let me just tell you, like, benefits of energy monitoring from the view of production and maintenance department, right? So if we see holistically for any energy for any industry, so there are uh, shop floor staff or the shop floor team, which comprises the production and maintenance team, and production, maintenance, quality, and all these shop floor department. And on the other side is the top floor department, is like senior management, CEOs, CFOs, shareholders, who don't go to the shop floor, but I mean, who are not involved in shop floor operation directly, right? But this energy monitoring and energy management is as equally important for both, all of them. So, uh, like, from the production and maintenance point of view, this energy monitoring or management will help you in reducing your maintenance issues, because uh, the moment we see the energy consumption pattern is getting changed, there must be some kind of maintenance issue. The production time will be more, because the turn time will be reduced. Any failure which we can predict by just monitoring the energy consumption, the production cost will be reduced drastically. Plant safety will definitely be increased, and penalties, as I already said, that there are so many penalties which are incurred because of discoms, tariff plan. We can avoid these penalties from senior management, and this is very, very important, that ease of availability of information is just a click away, right? I mean, they don't have to, I mean, because even though they want to have this type of information from the productivity, I mean, it's not handy, right? So it has to be available, it will be available to them, right? So they have different view to look at the energy consumption from the cost point of view. And suppose, say some unit is a job worker unit, right? I mean, they have to load the cost of energy in the job processing, right? So they will have a better understanding if the kind of job is getting changed, how much energy cost I need to add on this job processing. So sometimes what happens, I mean, we take a job and then we find out that, I mean, the cost of energy was too much for this type of process, right? And that job goes in a loss. And same is the case, like, I mean, if we may be charging, we may be asking for more, and we may lose the order, although we had a buffer. So it's very important from costing point of view. And once you declare that your facility or the uh, factory is completely sustainable, and you are monitoring all that data, you are managing your energy and facility, everything. So the confidence of your stakeholders will be increased drastically. And of course, the moment you start putting yourself, I mean, see, the thing is, once is like we are managing, and second is like we are flaunting, right? I mean, whatever we are doing, we need to display to everyone, right? So the moment we start showing that, I mean, that we are responsible people, our corporate strategy is very responsible towards the environment and the social structure. So the moment we do that, the funding will be easier. The shareholders or the investors, I mean, they have a certain type of confidence in you, and the cost of energy is definitely be reduced. Showcase as CSR and Go Green initiative. These are the benefits which these are, I mean, I would say intangible benefits, which will be much more than the cost of energy reduction cost. I mean, what you'll be getting. So I just here I'll just touch about the solution which we are offering for monitoring of power and energy consumption. So this is like the name of this solution is Power Profit. The name itself, it says that it will power your profit, right? So you will get the profit out of the power, and you will power the profits. So it helps you in monitoring the online energy. I mean, it helps you monitoring all the energy parameters online and centralized. So you can view each and every parameter of your power. And now, when we are talking about energy consumption, so the only power, the parameter which comes to our mind is kWh or kVh, right, or the units, but or power factor nowadays. But there are so many other information which are very helpful. The moment I mean, we deploy these things, we train the facilities or your team, so that, I mean, how to monitor all that data and how to make the most out of it, and which will help not only just to reduce the energy consumption, but also to make your facility safer. And it tracks all the points, like to monitor the balance or unbalanced load. All the parameters run out of the machine is very important. Like, I mean, if suppose we have a scheduled maintenance of the machine, what we do is, like, I mean, every 3 months, if we plan a schedule, right? But the problem is, like, it may have not run that many hours, then we should plan the maintenance, right? So we may be either doing overdoing maintenance or maybe underdoing maintenance. The moment we start monitoring the run hour of the machine, and the maintenance schedule will be easily fixed, and this will be uh, you know once suppose you are getting run hour of all the machines centralized at your desktop, right? And then you can just say that, I mean, this machine will be under maintenance at, say, 500 hours. So the moment you have the 500 hours, you'll get a notification, and then you can make it down for maintenance, right? So this will be helpful in equally dividing your maintenance job, and the downtime of the production will be less, and overdoing of maintenance will also be reduced. And I mean, this run hour is one parameter which is not directly calculated. I mean, it's an indirect calculation just because of the energy consumption, right? So if energy is not being consumed, that means the run hour is zero, right? So the salient feature of the product is like it's a desktop or local server based, or it could be cloud based. I mean, we are providing all that information over the cloud. Uh, all the critical items, alerts are there, preventive maintenance schedulings are there, real-time information, the power quality. Power quality, I mean, we have not discussed because the time is very limited, but I would say quickly that for power quality, there are four major parameters. One is like unbalancing of voltage and load, power factor, uh, voltage variation, and harmonics. So these are the major power quality parameters, which not only reduce your energy consumption, but also very important for your safe utility operation. Scalable, I mean, you can connect as many as devices there. Uh, Summarize reports, we can provide the summarized report over the email, over the SMS, and this can be integrated with your ERP or MI system. In many industries, have started using Google Sheets for their production data and all. Uh, we can integrate that energy management system with your Google Sheet, so that you will have a combined information system. From there, you can get your production data and energy data, and then you can find out your specific energy consumption. So this will become, I mean, the moment you have production and energy and other resources, I mean, this is just a start, right? I mean, I would suggest that you can further integrate your environmental parameter or the physical parameters like boiler pressure or compressed air pressure, the the amount of steam generated, the amount of steam consumed, the amount of compressed air being consumed, or I would say what else, like uh, or any other. I mean, I'm not able. Yeah, the humidity of your humidification chambers, or like, I mean, uh, how much power water is being consumed. So all these parameters, once we have, so this will make you a centralized location where you can fetch all that information. This is true IoT-based solution. This is basic architecture where multiple of devices are connected through cloud, and the technology which we are using here is the push technology. You are not pulling the information will be pushed to you. So it will make it easier for you to grab the information. Uh, it's again same thing, right? I mean, here the display. I mean, you can put the information across your production plant. You can make the information available across your network servers, so people can fetch that information from anywhere. This is one sample dashboard here. This is a very detailed one. I mean, mostly used by utility people. They can monitor the utility, how the utility is behaving. Uh, like for example, these are the summarized information where we are getting per day basis. Average power factor or average energy consumption, and these are the running parameters which we can see it online and offline. Uh, so so this is I'll just touch base with some of the case study. I mean, one especially for one textile unit, they had a 33 kV line connection, and they somehow, I mean, they were not getting stable voltage from the electricity board, and the distribution company was not able. I mean, they did not accept that they are not providing stable voltages. I mean, especially in during night time, it was going very high. The problem was like, I mean, how will they provide that information to them? They approached us. I mean, we provided this solution, and they started logging this information about the voltage variation. They went to the discom, and they said that was, I mean, this is what we are getting. Earlier, they have almost decided to go for automatic voltage regulator, so that they will have a stable voltage, and which was costing them somewhere around 45, 50 lakhs. I mean, it was at that time when the management had to approve this budget. One person suggested that, I mean, they knew about our system. he suggested, why don't you go for this? And we did this exercise for 15 20 days. After showing this data to the discom, they accepted that, okay, I mean, there is something wrong, definitely. So, and they got it corrected. So it was huge saving of around 50 lakhs rupees for them. So this is one, and after that they have started monitoring various parameters. So uh, I mean, if I have to talk about the ROI, they must have got their ROI in minutes, not in days or months, right? So same is the case. Various cases like who are procuring power from exchanges, they can schedule their, you know, they can they started bidding based on their energy consumption patterns. So this is a list of some of our esteemed customers. Thank you so much. Uh, if any questions, sorry, I have not gone through the chat box, so there may be some questions. Please feel free for any questions you have.
Okay, so everyone, probably all of you have enjoyed the program and probably have benefited out of Mr. Manish Jain's detailed speech about the energy management system and how it can be applied into the textile value chain. So if you have a particular question which you want to ask right now, or of course, the contact details are available on the screen right now. You can contact the company on the mobile number.
Also, Maniji, there are two queries which have been asked. One is from Mr. Nagrajan Kalyan Sundaram, who want us to share what are the benefits of solar system.
Right. Benefits of solar system are huge. Nowadays, the cost of solar plant installation is very low. People have started benefiting. I mean, they have made almost. I mean, who have deployed solar plants around 4 years back. Their solar plants are free of cost now, so they are enjoying free electricity. There are many benefits, and of course the cost of solar cells are going down. So government is giving the rebates on if you have a solar installation. So I mean, if you can just tell me like which electricity board, which state electricity board you are from, and then we can just see what are the benefits, because many electricity board have their own benefits in that.
Another question is there from Mr. JV Singh. Have you done any process automation in spinning industry to get
Oh.
energy efficient? If yes, please name the industry name.
No, I mean, we have not done anything specifically for energy efficiency for spinning mill. We have done mostly different type of automation for that, for processing industry, garment industries. Yeah, so not really for any spinning mill energy efficiency.
All right. Uh, is anyone interested to ask any other question specific to automation, energy monitoring, any other query on the electrical side that you may be interested in? So, over to you, Dr. Thakkar.
Hi. So if there are no more questions at the moment, as I said, you can again get in touch with Mr. Manish Jain through the contact details which are displayed on the screen at the moment. So let us put an end to this. And before that, of course, I would like to thank particularly Mr. Rajat Jain and Mr. Manish Jain for making this program happen. This is thoda hatke program from the Ahmedabad unit. As I said, we normally carry out the programs based on spinning and weaving technologies, which we are expert at. But yes, of course, this is equally important, as I mentioned in few initial slides. So thank you, a lot of thanks to Mr. Jain for making this program happen. It was you were after me for quite a long time, and ultimately we are able to happen it. And there are a lot of participants who are actively involved, and they are listening to it. Probably they'll get in touch with you maybe later. And also I want to thank each and everyone who was involved in making this program happen, particularly the president, Mr. Hasmukh Bhai, and the whole team. So, thank you all, and let us call an
Th-
end to this particular program.
Thank
Thank,
you, Dr. Tucker. Thanks,
thank
everyone.
you, thank you
Thank you.
for, thank you everyone for attending. Thanks.